Hello everyone and welcome back to the channel. It's been a little while, but we're back. So quick recap. Last stream we went through and created a parameter store with AWS to keep track of all of our parameters we're going to be using. So all that is set up. Now we can dive into the code layer of our DynamoDB integration. And let's get into it. So last a couple days ago, I actually did a stream where I did all this DynamoDB integration. I did not record it. So I thought today for this stream, I'm going to quickly recap everything I did and sort of the order I did it. That way it's on video and people can reference it and so on and so forth. Alright, so first thing to do is log into the Aws Management Console. I'm in with an admin account to get to the Dynamodb database stuff. So let's go to Dynamodb, tables, and we have a user credentials table already. And we can look at items, and it's all empty, but it is here. And we'll reference the hash key and such in our code, but it'd be good to see this up. All right, so next thing that we did was look into the documentation for DynamoDB from AWS. So this is their official documentation. It goes through how to do your CRUD operations. So CRUD is an acronym CRUD, create, read, update, and delete. So that's your normal database operations that pretty much every database interaction will have. You'll be able to create an entry, read an entry later, update the entry, and then delete that entry. All right. So documentation goes through those CRUD operations. And there is also near the bottom, it talks about a Dynamodb Mapper class, which is what we use. And this is sort of like a JPA or Hibernate sort of parallel where you have your Java representation of your database using annotations. You say what the table name is, what the different attributes are, and it does the mapping to your Java object, and then you're mapping to your DynamoDB database. So we will use this Dynamodb Mapper in our code. So the first thing we need to do is, in order to work with DynamoDB, they have an SDK that we can use in Maven to import into our code. So we can go to Google and do DynamoDB Maven. The first thing that comes up is the Dynamodb Maven dependency. So usually just grab the latest version. It has the latest bug fixes and tweaks and security enhancements, so on and so forth. So copy this Maven dependency, jump in our code, and I put it in as a dependency in the Maven POM file. Wait a couple minutes and that should import that down for you. So then the next thing we did was look at what this needs in order to work. And this needs a couple of beans set up. So if we look through their example code, the overall interaction is ddb.getItem and so on and so forth. So this ddb object is Amazon DynamoDB client builder.default client will give you a Amazon DynamoDB object. All right. So we need that bean. You can also it's probably with the mapper code. in order to create this mapper object, you pass in the client, so an Amazon DynamoDB client. They have a builder for it. And we just do a standard build. We get the client, and then we pass it in to create a mapper. So for us, we're using Spring, so we want Spring to manage these two objects, or beans. And so we will create a configuration that will have Spring manage them. So that's the first thing we did, was create a database package. So this is under com.autotrader. We have a new package called database. And similar in our test package, we have a new package called database to match. And if you want, you can do this as test-driven development if you so desire, and create the test class and then the objects that it references. In the stream, I didn't do that. I just made the packages first and then made a simple integration test class to start testing with live. But I digress. Alright, so after you have a database package, create a new class. I call it database config. I'm keeping the name of it a bit more generic on purpose. Right now we're using a DynamoDB database, but in the future, if we have Oracle or MySQL or any other databases, I don't want the name of a class to be bound to the type of database it is. So I don't want DynamoDB config or MySQL config. We just want database config. And this will take care of any configurations for any databases that we have in the future. All right. So since we want this managed by Spring and it's a configuration class, we're configuring our database beans. We have the @configuration annotation for the class. And then we have two beans inside of here. The first one to talk about is this Amazon DynamoDB bean. So again, going back to the example, they make the client and then pass the client into the Dynamodb Mapper. So we need to do the same thing by creating this client bean. So it's going to return the same type, Amazon DynamoDB. Give it a method name, and it's just going to return the client builder, .standard.build, same as documentation. And I'll have a link to documentation in the description for you all to reference if needed. All right, so after we have this bean, next is we need to get the DynamoDB Mapper object or bean. So it's another bean, so have the @bean annotation. We pass in the client, which is an Amazon DynamoDB object. And since this is in the same configuration class, when it gets this bean definition, it looks at the signature and says, hey, I need an Amazon DynamoDB object. How do I make that? It looks up here and says, hey, this bean returns to me a Amazon DynamoDB object. So it knows to create this bean and then inject it into this bean. So it's sort of one bean relying on the creation of another bean in order to be instantiated. Then all we do is return a new DynamoDB Mapper object, passing in the client. And then now we can inject our DynamoDB Mapper bean into any service classes that we want or anything that needs it, and be able to do all the operations like saving and retrieving, deleting, so on and so forth, to our DynamoDB database. All right, so that's our configurations in order to use DynamoDB. The next step, sort of again following this documentation, we need a Java object representation of our database. So this is going to be a model So I made a models package under the database package. So we can have multiple models. We can have a model for user credentials today, and we can have another model for a user account or trade history or application configuration, whatever databases that we have in the future, we'd have its own model representation in our code. All right. I'll talk about this abstract class in a little bit. That was sort of a refactor in the stream to make it more generic. So we'll jump into the user credentials class. Again, ignore this extends for now. You can go ahead and code it in if you're following along live. But I'll talk about why I put this in near the end of this review. All right, so we have a user credentials class. We want to model this as our table. And I also do add data to have Lombok do all the getters and setters to strings, so on and so forth. So that is part of this. All right, so if we look at the documentation, there's a few annotations that's really key on how DynamoDB Mapper classes work. The first is to tie the class to the correct table. And that's using this DynamoDB table annotation. So even though it's the same name, we want to say the table name is going to be linked to is called user credentials. If we look at our console, that is in fact our table name. So it's at DynamoDB table, and table name equals, and then our table. And make this look consistent, we'll do spaces in between. So the next couple of annotations to look at is keys. So quick recap, DynamoDB has two types of keys. Everything has at least a hash key. You can think of it like a primary key in Oracle in a way. So the annotation for that is at DynamoDB hash key. And then you give the attribute name that it's going to be linked to. In our case, the hash key is user. And so in our code, we have a DynamoDB hash key, attribute name is user, and it's a string, so we define the variable, and we should be good to go for that. The next type of key in the DynamoDB lingo is a range key. And this is sort of like a composite key in a way. So you have the main hash key and then a range key to further identify the attribute. Range key is optional with DynamoDB, but it does help to limit the read and write units towards your database. So again, quick recap, DynamoDB, their billing model is set on the number of reads and writes to your table. And so if you do a full database scan of 1 million records, it has to read through all 1 million records. Then it's going to charge you for those 1 million reads. If you put a range key on it, so a subset basically of your table, it might only read 10 units instead of the full 1 million. So you're going to get charged those 10 read units. So this is a way, if you're getting charged quite a bit for using DynamoDB, you might want to look into properly using a hash and range keys to limit your read and write units. All right. So that said, our range key is broker. So in our code, zoom in a little bit more, we have a DynamoDB range key annotation. We link it to the broker attribute, and it's a string, so we have it private string broker, and that's that key. Next, to mention real quick, the other type of annotation that's really common is a Dynamodb attribute. This is basically any other elements or attributes or columns that your table would have. So you can have n number of attributes, you can have 0, 100, doesn't really matter. And each one of these will get tied to a attribute in your table. So we played around with it in the stream live. But in the end, I did keep in a token attribute. So at Dynamodb Attribute, gave it a name token. And then we define the variable as a string. And this will represent the security token that we retrieve from Robinhood that will then pass into other calls as we use their API. All right. So that will wrap up our model. So we have a hash key, range key, an extra attribute. We tie it to a specific table. So this all is set up now. The next piece is sort of the meat and potatoes, so to speak, of our code that we did. And that's defining a service for our code to call that does actual things. So it'll do the saving, reading, and deleting. So we'll get started talking through this. So I call this database service. Do the @service annotation to have this managed by Spring. And a quick little aside, a design pattern this would represent would be a proxy pattern, I would say. So we could not have this class, and everywhere in our code that we want to save our data, we would inject in the mapper object in our config, so this Dynamodb Mapper class, and then call mapper.load or save or whatever operation we want to do. And we can do that all throughout our code. Instead, what I'm doing is creating a proxy for our code to go through in order to do our database operations. So now, if we want to interact with our database, you're going to inject our database service class as a proxy to our database. Then you'll call save, read, or delete as you need to in order to do your database operations. So instead of interacting with the database directly through the mapper, you're going to interact through the service to get to the database. And that way, if there's any changes to our database layer, if we want to swap out and use MySQL or any other type of database, theoretically, we would only have to change our database service, and the rest of our code won't change, because this is what's the underlying stuff that saves our data, right? As long as we keep the signature called save and pass in the class that we're saving or an object that we're saving, this is the thing that knows it's a Dynamodb database. We can swap this out to MySQL and then say MySQL.save whatever. And the rest of our code doesn't need to know about anything about the database. It just knows it injects in the service, it calls save and gives it what you want to save, and it saves it into a database somewhere, somehow. So that's a good use of a proxy pattern in order to create this service. All right. So going back to where we were, @service annotation to have this managed by Spring. Next, we do need to inject in our mapper class. I chose to do this via Constructor Injection. So I have a constructor for the class. I have a Dynamodb Mapper argument, normal constructor kinds of things. Don't know what I did. There we go. I do the @AutoWired annotation on the constructor to tell Spring that it needs to wire in any of the arguments into this constructor. So it says, all right, I need this Dynamodb Mapper. Where do I go get it? It looks into its context and says, hey, this is a bean that defines it. How do I create this? It looks at this argument and says, all right, I need a Amazon DynamoDB bean. How do I make it? And it goes up here, and this creates the bean, gets injected in here. This creates this bean, which gets injected into our service. And all that happens on startup, so it's a one-time cost to create everything. And during runtime, you don't have to recreate all these beans. All right. So now we have a auto-wired bean coming in for our mapper. So the next thing to talk about before we get to the rest of these methods, as far as order of programming I would do and what I did in the stream where we did this, was go ahead and create the integration test class. Go ahead and minimize that. Well, I'll expand it. So in the database package, I created a database service IT for integration test. And I have this test class. And then I started to use this to be able to run and compile and make sure stuff is progressing and doing what I want it to do. So the first thing I did was add some annotations in to make sure all of my beans were created successfully. So since I want Spring to create those beans and inject it into my test class, first I did a run with annotation and used the Spring Runner class. And then in order to create a Spring context, I did @Spring Boot Test, and that would make a context that tells the test class, hey, I need you to go and create these Spring beans in order to inject in to test with. And then I auto-wire in my database service class. And here you can just do if database service equals null, something bad happened. You can run this, and if it was not able to create the beans and be managed by Spring, this would be null, and this would get printed out. You know something is not correct with your Spring setup. So we did that. Our database service was created and injected successfully, so we know we're good in that regard. So then next thing we did was create a scenario or a test case called CRUD test. So this is create, read, update, delete. Another quick little aside, you could create separate test methods for each one of these operations. So you can have a create test, read test, update test, and delete test. The reason I didn't do that is because the order those methods are executed and tested is not guaranteed by default. There's ways around that. You can specify the order in which to do the test cases, but I didn't want to get into that, so I did not create separate test methods for different operations. To me, if any of these things fail, it's bad. If I can't create something, then I can't read it, and I can't update it, and I can't delete it. So I put CRUD test as an overall test the main 4 operations in one test case. All right. So first thing that I did was create a new user object. I gave it just some dummy values, U1, B1, and T1. And then I called database service.save and passed in that new user. At this point, we have not coded this save function, so it would fail it wouldn't even compile. So you can go over to database service and go ahead and create this method. But the intention is after running this part of the test case, it will save in our database, and we can see in the AWS console this new user. Go ahead and put a breakpoint here for when we run this, and demo, we'll see this new user being put in. Alright, so if we switch back over to our database service class, I will change this back to what it was originally. So user credentials, import it in. So before the refactor, I just had user credentials as what I'm saving, and it looked like this. All right, so all we're doing is saying pass in a user credentials object, and I will save that using the mapper. For DynamoDB, we do not have to do an insert and update separately. So if it's not there, it will just create and insert the record for you. If that record already exists, it will update the record. So this will do both the C and the U for CRUD with just calling save. And that's why I only have 3 methods and not 4 in this database service class. All right, and that's as simple as that. So mapper.save and pass in the object. So the first time you run this, you will actually not be able to run it. It will fail and it will give you an error, and it will be your integration with AWS that has an issue. If you recall, when we did the parameter store, we went up to the run configuration, went to edit configurations, and passed in special arguments that gave the access key for our admin account and the secret for our admin account as our authentication authorization mechanism to say we are authorized to use this service in AWS. Whenever you right click and go run whatever test, it will create a new run configuration for you. And that's why I have a few of these guys up here. Since it created a new run configuration, that arguments section is empty. All right, so go ahead and run the test, expect it to fail, but it should give you your configuration. You go edit configurations, and it's off screen, so you don't see my access key and such. You should already have that environment variables filled in from the parameter store video a couple videos ago. You should be able to copy that and paste it into the new configuration that it created for you and be good to go. So once you do that, you can rerun the test case and it should all work for you. So yeah, so we'll go ahead and run this. Well, kind of. I meant debug, but we'll let it go real quick. It takes a little while for it to boot up Spring and all that. Alright, let's do this again, but debug for me. That way it'll break on this guy, and we can look at the console, AWS console, to see the record inserted. All right, so it's at the breakpoint. We go over to our console, view a search. We see our item in our table. We have user U1, broker B1, token T1. That's exactly what our object had. So the save works with creating a record. So next I wanted to assert. So next I wanted to read. So how does that work? I want to say if I give you a hash key and a range key in the class that it's supposed to be, I take that back. Getting a little bit ahead of myself. I'll go ahead and push play here. Again, a little bit faster at the end. This originally looked how do I want to do this? Let's comment that out for now. So first iteration, I did not give it the class. I just had a read method that says, if I give you a hash key and range key, I want you to give me back my object. Sure, it has issues with generics. So let's do this real quick. There we go. So ignore the comment and stuff. I'll again come back to it at the end. But basically I had a public method, returns the user credentials object, method name is read, I pass it a user and a broker, and it calls load. So this is another method given to Aspire Mapper bean. I want you to load in this class with the user and broker I give to you and give it back. So apparently this doesn't compile anymore because I've been commenting out stuff, but that's pretty much it. So this would give back our user. So we pass in U1 and B1, which is the user we just created, so we know it's in our database. And we make sure with assertions that we expect U1 for user, B1 for broker, and T1 for token. So it should give us back the same object. And it did. So you can do that on your own. So you can put these assertions in and make sure that you get back that data. All right, so that is create and read taken care of. I want to make sure the update works. I know save would work, but to make sure through a test case, I set my token to T2 to update my value for token. I again call save on my new user. And I do another, that's why it won't compile. I do another read with the same U1 and B1. And now I expect T2 for my token. Again, this worked fine. Test case passes. You can go ahead and do that if you want. See, we have a create, read, and now update taken care of. And the last thing to do is make sure we can delete records. And a small little aside for deletions. There's a couple of ways to actually delete data. A hard delete and a soft delete. And they both have their purposes and reasons why you want to do those. And what is the difference? A hard delete is a real delete. It's no longer in the database at all. So if you look in your database, you will not see that record. That's a hard delete. That's, I don't want the data anymore. I want to get rid of it. I don't want to keep it for anything. You do a hard delete. Another way to do a delete in your software or your architecture is a soft delete. This is usually a flag on your record that says, is this record deleted, true or false? If the Boolean is true, so it should be deleted, then you'd never return it from any queries, you never use that record anymore. It's logically deleted. It's no longer usable in any of your code or any of your applications. But if you need to keep it for regulatory reasons or just triage and account, maybe you want to give your users the ability to come back to you, so you don't want to lose all their information. So they sign up for your application and they say, I don't want to be a user anymore, and they go ahead and delete their account. You might put that as a soft delete, and then if they reapply or come back to your application, they still have all of their profiles and stuff from when they were users. And you probably want to disclose that, say, they might get curious why all their stuff is still there if they were deleted. But in any case, that's sort of the two different options for deleting. Hard delete, you physically remove it from the database. Soft delete or a logical delete, it's still present in the database, but there's a toggle on that record saying don't use this for anything. They don't really exist anymore, so on and so forth. So, all that said, for our case, we did a hard delete. So, again, we'll put this back to the first iteration. So we pass in a user credentials object that we want to delete. The Dynamodb Mapper has a delete method on it. Pass in the object you want to remove and deletes it for you. I did play with this a little bit, just kind of curious what would happen in different situations. So if your object is not in your database to be deleted, it won't tell you, it won't throw an exception, it'll just, your record's still not there, so it's going to return back fine and you can go about your day. Alright, so to me, I could see it both ways. I'm not against that idea. If you want to be super careful, you could say I want to first load this user, and if it comes back null, so this read, when you call load with user and broker, I believe, I'll test this real quick. If it doesn't exist, it will return back a null object. So it won't throw an exception or anything, it'll just return back null. So then you can, on your delete, say if my load of my user credentials is null, then throw an exception saying user is not found to be deleted. I can't delete something that's not there. But again, for me, I'm fine with how they did it too. I mean, at the end of the day, this object is not in your database, and that's why you're deleting, so I don't really care. Alright. So we have we call this delete method. Pass in that user object we've been using to test with. We call read one last time to read in my user. Now I'm going to assert null this deleted user. So now when I read, I should no longer be able to find this user. And we could do a null object pattern for this instead of passing around null. I might do that next video, but for now, null is fine. All right, so quick recap. Go ahead and put a breakpoint at the top. This will create a user, save it. We'll call read user, giving the same details. And we expect U1, B1, and T1. We update the attribute for token to T2. We again save that user. Then we read the user again. We make sure the T2 was updated correctly. Then we delete that user and make sure when we then read to get that object back, it returns back null. So another nice thing about this test case, as long as it passes, when we look at our database, we won't ever see this dummy item. It will be created, it will be used to test reads and writes and such, and it will be deleted, and it will be all cleaned up. And you can rerun this as many times as you want, and everything will work. All right. So let's go ahead and restart this in debug, and we'll kind of walk through and see everything happen. All right, so hit our breakpoint. We'll go ahead and, don't want to step over, get to our save. Go ahead and let it save. Look at our DynamoDB, hit search. We have U1, B1, T1. And that's what we expect, U1, B1, T1. So let's skip ahead. And we set the token to T2. We call save. We again search, and our token is in fact T2. Skip over these. Now we call delete. We do another search, and our item is no longer there. All right. So our test case works. We can show we can create, read, update, and delete from our DynamoDB table. So what's the next thing? Something neat to show real quick, and I will get rid of these bottom items. Boo. Too much commenting going on. So one of the powerful features of DynamoDB is that it's a NoSQL database. And what do I mean by that? So a SQL database like Oracle, MySQL, things like that, you define your database and all of your different columns and how they all relate to each other. And if you ever want to make changes to your table structure, you have to update your database. And depending on your change, you might have to update all your records that's already there. You might have to recreate things. You might not be able to do different types of changes because your data will no longer be compliant with the new model. So it's a bit of a pain to make database changes to a SQL style database. A NoSQL database is sort of the opposite. It does not have a strict structure to adhere to. When we created our DynamoDB table, all we gave it was what the hash key and range key was and the table name. We did not define any attributes. We didn't define any columns, all that fun stuff. So what that allows us to do, if we go back to our user credentials model, if we wanted, we can create a new attribute called test. Okay. Back in here. New user dot set test and say blah. Go ahead and rerun our test case. We did not make any changes to the actual database in AWS. We did not have to run any database update statements or anything. All we did was change our model to say, hey, we're going to have a new attribute called test. So then if it's present, it will load into this guy, the mapper, and if you have data there and you save it, it'll make that new attribute in your table. So our test case passes. If I now search again, I have this new attribute that just magically pops up since we've added it to our model in our Java code. So this is a really powerful way to change our database model without doing any actual database changes. So we'll probably use this quite a bit as we go through like a proof of concept, getting this all set up. We'll find out, hey, we need to have this attribute, we need this field, we need this value, whatever it might be. Now all we'll have to do is add it to our table, our model. So let me go ahead and delete that. And that's how I put in this token attribute. And this no longer has test. Go ahead and replay this. And we should still have it pass. And I don't know if it will stay here or not. We'll see. It might throw an exception. So it may not know what to do with that extra field. Alright, so it passes. So our search is still present, so we didn't remove or delete this thing. but it also worked. So even if we remove stuff from our object, it's still there in our table, which is interesting, but fine. All right, so there's that little tidbit that we kind of worked through in our live stream that didn't record. So the next thing to talk about, and this is sort of the wrap up to the video. Now that we have database service, now we have this class. At first it had all these references to a single object. And I knew we were probably going to have multiple tables. We were going to have the same save, read, and delete to all these different tables. I wanted to abstract this to say if I give you any type of object that's from our database, I want you to be able to save, read, and delete that object. So all this is saving what I pass in. So there's no real transformations or logic here to say do this if it's this object, do this if it's a different object. It just says whatever is here, call save. Similar for delete, whatever is here, I want to call delete on it. The only little caveat was this read. In order to load the record into our code, we had to give it a class that represents its model. And we were still able to use generics to solve that, which is fine. So what did I do to start this refactor? First thing I did was create the database model abstract class. So what I'm doing here is I'm creating this abstract class that this is a database model. Anything that extends this class is also a database model. All right. So next thing, in my user credentials object or class, I extended that model. Now I'm saying this class is a database model. Now that I did that, my database service class can take in a database model to save. So now I can pass in anything that extends database model, I can save it. Same with delete, since that's the other simple method. So I updated that, and I say, as long as I pass in a database model, I want you to delete it. And that all worked fine. So the last one was reading. So how do I read in a object and know what class it needs to be modeled to? And that's where I used some generics to say go ahead and get rid of these comments. Get rid of that. So now I'm saying there's a generic T which extends my abstract database model class. And it will return back whatever was this generic class. So I pass in a user credentials model for T. It'll return back a user credentials object. Alright, so then the last piece is this is a class T, so this is a class object, and load takes in a class object. So what I need to do is pass in my model to here, and everything is ready. And so now what I have is a read method where I pass in, for now, I'll rename this here in a moment, a user and broker and what model it goes to, and it'll load in that model with these two parameters that it looks up, and that's what it returns, this generic T, which is an extension of my database model. So I'm going to go ahead and say hash key there. Range key here. Alright, that makes it a little bit more clear. Now if I give it a hash key and range key, I'll load in that. So something else I can do is not every database is going to have a range key. So I can say if string utils dot is empty range key. So I want this to be the opposite. So it's not empty. Return mapper dot load model and hash key. So if I pass in a range key, then it will load that in. If range key is empty or null, then it'll just load in the model based on the hash key. So now my database service, if I create any new databases, in DynamoDB at least, all I need to do is extend my abstract class. I can give it whatever hash keys and range keys and attributes I want, but I will be able to save it in my database using the same database service class without making any further changes here. So there should be no modifications needed for this class in order to do any type of reading, deleting, saving of data. And real quick, since I put this back, update these. There we go. And I don't need to keep this guy anymore, so I'll uncomment those. Rerun this test case, should still pass. Make sure everything gets cleaned up, and that will be it for this video. Did not work. No range key value present. Oh, the wrong one. So if it is empty, I just want to load in that. Hooray for test cases. All right, there we go. Let's go back here do a search, and this is cleaned up. So that is pretty much the video for today. I'll go ahead and go to my terminal, git status, git add dot, git commit -m. We'll say tweaks to database service. Kind of curious some of the changes I put in here, but doesn't matter. And push that up. Now our remote repo is all up to date with what we've been working on. So to conclude, kind of walk through DynamoDB and our Java code to interact with it. We created a couple beans to use. We have a database model represent what our database looks like. We made a database service class to act like a proxy. We did the CRUD operations. We have an integration test to make sure it works with Amazon. Next video, maybe 2 videos from now, we'll go through and write some unit tests to reinforce everything that we've done in test cases. And that will give us a strong foundation to make sure that if there's any changes to class, we know about it, it won't break anything. So that's all for code-wise in the video. And real quick, this sort of other updates about the channel, and I'll probably put this in the intro next video as well. That way everybody knows about it. But pretty excited. The next step in my growth as a business and this channel is to have a Patreon integration part of it. So I have a Patreon account now. So if you all like what this is has been doing and is valuable to you, I would ask that if you're able to, go ahead and become a patron. It really helps out a lot to me and gives me motivation to keep going. And the way it works for now, it's just a single tier. It's $3 a month, and it's going to give you early access. So you're still welcome to join live as I go through things and get things obviously live right as I do them. After that stream is done, hopefully next day or two, I'll get it ready to be uploaded to YouTube. It'll be unlisted, but if you're a Patreon patron for that $3 a month, you will get that video as soon as it goes up on YouTube. Probably after a week, maybe 2 weeks, I will then make that video public. That way the rest of the world that's not a patron can view it and keep track and follow along. So that's a way to give you all that want to financially support the channel a little incentive and perk. So there's that. At some point, I'll probably make the live stream another tier, so that if you want to be on the live stream and watch through live as developed, it'll be a tier, and then the early access would be a lower tier, and then public for everybody else about a week or 2 later. So those changes will be coming up at some point in the future. And the other tier I'm thinking of, and this would, to me, be a lot more fun, a lot more driven by the viewers, is for you guys to submit features and direction on where you want this product to go. So obviously I would want to do the core pieces that have to get in, but after that, if there's a feature that you want that we haven't gotten to yet, or if you're on such and such broker and you want support for that broker in this application, then you can add a certain tier. I don't know what that would be yet, but submit those feature requests and would prioritize those features from the Patreons above other things. So I'm hoping that after we get the core functionality built out, you guys would help drive the direction you want to see this product go to in the future. Hopefully that makes sense. I'm pretty excited. But that is pretty much it. So I still have my blog. I need to get that updated with the last videos. And the blog, I'm wanting to have the blog come out the same time the YouTube video goes public. Then there's the Patreon if you want to get early access and help to financially support the channel. And obviously YouTube is the video hosting I'm using for the moment. And I believe that is it for updates on the channel. So if you all have been watching through, thank you very much. I'll try to get this uploaded to YouTube in the next day or two. And then again, if you're a patron, you'll get that early access. If not, you'll be able to see the video in a week or two. And with that, I bid you all adieu. And until next time, hopefully you all enjoy the video. And we'll talk to you later. Thank you all. Bye.